Hello students, today we are going to discuss chemical kinetics from NEET paper which was held on 27th May. So let us begin with the chemical kinetics questions starting from 166. The first question is, for a reaction between A and B, the initial rate of reaction 1 is measured for various initial concentrations of A and B, and the data is provided. So basically, whenever you look into the data like this, we understand that this is basically determining the order of the reaction, right? So based on initial rate method. So basing on that, we will try to make the equations as, since there are three set of experiments which are being done between A and B. So initially the first set of experiments says that the concentration of A is taken to be 0.2 molar and 0.3 molar, and rate corresponding to that everything is being given. Similarly for the second and third, so basing on initial rate method, they are asking us to determine the overall order of the reaction. Okay, now what we are supposed to do? So for each set of experiment, we need to convert that into each one equation. So if that is the case, for the first equation we will write R1 is equal to so here we will write R is equal to concentration of A is how much? Basically, we write rate law as K into concentration of A, which is raised to the power X, and similarly concentration of B, which is 0.3 raised to the power of Y, and rate is also being given. So instead of writing the rate here, we can write the initial reaction rate, which is given to be 5 into 10 power minus 5. Okay, similarly in the same way we will also write for the second experiment, that is 0.2, 0.1, and this one. All the three equations we will write. Okay, now let us write completely how are we going to do. Okay, so let me erase this R, and then we will write the value of R. So initially what is the value? This is 5, right? So 5 into 10 power minus 5 is the rate which is given in mole liter inverse second inverse. Okay, now let us say this is equation 1. Okay, what is equation 2? So equation 2 says that it is for concentration of 0.2 molar. Rate I will write first here. So rate is equal to 5 into 10 power minus 5, which is equal to K into concentration of A is 0.2 raised to the power X, and B is having 0.1 molar raised to the power Y. So this is equation 2. So who is similar way we will also write equation 3. So what is equation 3? So 7.5 into 10 power minus 5 is equal to K into concentration of A is taken to be 0.4, which is raised to the power X, and similarly concentration of B is taken to be raised to the power Y. Okay, Y is equal to 3, third equation, right? Now what we do basically, so we divide two equations at a time. Now let us take equation 1 and equation 2. I'm going to divide equation 1 divided by equation 2. Okay, so hence what will happen, this rate and rate gets cancelled and you will get one value, and the concentration of A, that is 0.2 raised to the power X and 0.2 raised to the power X will get cancelled, and basically you will get 0.3 divided by 0.1 which is raised to the power Y. So let us do it. So if you divide these two equations, that is equation 1 divided by equation 2. So what do you get? Equation 1 divided by equation 2. So on the rate, 5 into 10 power minus 5 will get cancelled. So which is equal to K, and K gets cancelled, and 0.2 raised to the power X and 0.2 raised to the power X will get cancelled. And what is remaining? What is remaining? You will get 0.3 which is raised to the power Y. Okay, so now if you have to calculate, that is not 0.3 because 0.1 and 0.3 we can write it as 3 raised to the power y. Okay, one second. So this is 3. Okay, so 3 raised to the power y. Okay, so here we get 3 raised to the power y. Okay, now in these type of cases where the bases are not equal, right? So in such cases, what do we do is we apply log on both sides. So if we apply log on both sides, it will become log 1 is equal to log 3 power y. So how do you solve this? So you know that log 1 is equal to 0, which is equal to y log 3. Y log 3. So what is the value of log 3? All of you know that it is y into 0.4771. This is the value, right? Now y value will become how much? Y value will become how much? So y is equal to 0 divided by 0.4771. So 0 divided by any value will be once again 0 only, right? So hence y is identified to be 0. Okay, so similarly solving equation 3 and 2, okay, equation 3 and 2, we will also be able to get the other value, other power value, which is nothing but x. Okay, shall we do it? Okay, how do we do? Basically, have a look at the equations 2 and 3. So what is equation 2 and 3? So now I am going to divide equation 3 divided by equation 3 divided by equation 2. So what is equation 3? So you have rate value to be 7.5. So let me write. So you have 7.5 into 10 power minus 5. So divided by you have 5 into 10 power minus 5. Okay, which is equal to k and k gets cancelled. So 0.4, which is raised to the power x divided by 0.2, which is once again raised to the power x, and it is multiplied with the concentration of x, that is 0.005 raised to the power y divided by 0.1. Okay, which is raised to the, is it 0.1? One second. One second, students. Okay, 0.1 raised to the power y. Okay, raised to the power y. Okay, so now you have calculated y value to be 0. If you put y value here 0, this entire term will become 0, correct? So hence what will you get? Basically you will get equation 3. Okay, you get basically 1.5. 1.5. How do you get 1.5? If you cancel this 5 and 7.5, here you will be getting 1.5 value. So here this and this will be cancelled, this and this will be cancelled, and you will get a value of 1.5, which is equal to 2 power x. So similarly here also you need to determine the x value. Since the bases are not same, apply log on both the sides. Okay, so now log 1.5 is equal to log 2 power x. Okay, so now log 1.5 value will be 1761. Okay, so log 1.5 will be 1.5 will be how much? It will be yeah, 0.1761. Okay, so one more method also I will tell you. Basically, how do you get 1.5 value? If you divide 6 divided by 4. Okay, now take log 6 divided by 4. So we all of us know that log a by b is equal to log a minus log b, right? So log 6 value you can take it as log 2 power 3, right? So 3 into 3 into, because log 2 value are all of you are aware, 0.3010. So it will become 0.90, how much, 30, correct? So that value minus log 4 value, that is 0.4020. If you do, you basically get the log value of 1.5. Okay, log 1.5, which is also 0.1761. And log 2 power x can be written as how much? Because it can be written as x log 2, right? So if that is the case, here it will become x into, okay, x, I'll write. So here you will get how much? 0.3010x. Okay. Now what is the x value? So x, is equal to, how much is the value? 0.1761 divided by 0.3010. So which is equal to, once again, it comes out to be 0.58. Okay, so which means that x value is less than 1 and y value 0, and hence the overall order of the reaction will become between 0 to 1. So your correct answer would be option D. Okay, so next one. Hope you understood this. If you have bases different, then if you want to find out the value of the powers, then you have to apply log on both the sides. Okay. Then coming to question number 167. So this is once again based on complex reactions in which equilibrium is involved. So where we will determine rate law. Okay, now here in the question they have given the overall reaction. So where Cl2 aqueous is reacting with H2 and there is formation of sulfur and 2H plus, and there is formation of also Cl minus. Okay, now rate law they have given. Okay, rate equation for this reaction where rate is equal to Ka, Cl2 and H2O. Okay, since this is not a simple reaction or elementary reaction, the mechanism is being given. So they have proposed two mechanisms, among which is consistent with the rate that is given in the question, is what is asked. So how do we do? Basically take up the first mechanism. So what is the first mechanism? First mechanism is shown as, that is Cl2 and H2S, and the first step they are showing it as slow, and second step fast. So we all of us know that in case of complex reactions, the rate determining step will become the slow elementary step. So hence the first step is the correct one. Yes or no? Fine. Then if you make the rate law, considering the first step, that is one second, let us erase this so that I can show you how to do it. Okay, let us have a look. So slow reaction itself, if you are writing the rate law, it is understood that rate is equal to, what happens basically, what is happening, rate is equal to K into the product, that is Cl2 concentration term, and stoichiometry is not there, that is if nothing is written, it is understood that it is only 1. Okay, stoichiometric coefficients of chlorine, correct? And then similarly, what do you have, one second students. Okay, okay, see here, it is quite easy. Slow step, from the slow step we are trying to write, rate law. Okay, rate law. So how do you write? So we'll write here. So based on the slow step of the first mechanism, so where the rate is equal to what? K into Cl2 concentration and H2S. So which is H2S, Allah? Okay. Actually in the question they have given here H2O, which is wrong. So it need to be H2S, right? Because H2O is not part of the reaction in the reactant side. So hence this would be wrong. Okay, it should be H2S. It is not H2O. So make a correction there. So hence rate is equal to KCl2 and H2S, which is very much consistent with the first mechanism, slow step. So hence we can confidently say that the first mechanism is very much apt for the complex reaction, that is overall reaction, which is given in the question. Correct? So first mechanism is correct. Now we cannot just leave saying that first question is correct, first mechanism is correct. We also have to look into the second mechanism. If you look into the second mechanism, the first step is the fast equilibrium step and second step is the slow step. We all of us know that slow step is the rate determining step. So if you write the rate determining step for the second mechanism of the second step, slow step, so what do you get basically? So rate is equal to K into, what are the reactants that you can see in the slow step, that is Cl2 and also HS minus. Now have a look at the overall reaction. So where is the overall reaction? Here is the overall reaction. Can you see there, HS minus anywhere? This is Cl2 and this is H2 and there is no HS minus in the reactants. And hence we also understand that just look into the mechanism here. HS is formed in the fast equilibrium step. As soon as this HS minus is formed, this is actually consumed in the second step. Here it will be consumed. So hence the intermediates will not take part, okay, in the rate law, that is rate equation. So hence we say that this cannot be there. So if this cannot be there, what we are supposed to do? We need to once again determine K equilibrium to substitute this concentration term. So to determine K equilibrium, where we have to go? We are supposed to go to the fast equilibrium step. So how do we write fast equilibrium KEQ value? So we all of us know that K, that is KEQ is equal to, how do we write? The product of concentration of reactants, that is H plus concentration divided into, actually there is concentration of HS minus divided by, what do you have? H2, correct? You have H2. So this is the equilibrium. Now what you have to determine? You have to determine the concentration of HS minus is equal to what? So now if you write HS minus concentration, then it will become product of KEQ and H2, KEQ and H2 divided by concentration of H plus. Now if you substitute this entire value, that is this entire value in where do you substitute? In the place of here. Okay, here you need to substitute. If you substitute there, what do you get basically? R is equal to, rate is equal to K Cl2, so which is will be substituted by, once again here KEQ also comes, KEQ. Okay, and here you get basically concentration of H2 divided by H plus, so which is not consistent with the rate law which is being given in the question. Can you see? So here there is no H plus. Okay, so hence which is correct for us now? So for us, for this question, the only option that is correct is B, that is first mechanism only is correct. Okay, so hope you understood, the students. So this is based on what? So based on the reactions involving equilibrium, where we solve K equilibrium to avoid the concentration terms of intermediates in the rate expression. Okay. Now let us move ahead with the next question. Okay. So what is the next question, students? Meanwhile, you just have a look at the question. So what is the question basically? 168. So 168 is saying that the reaction L2M, that is L is the reactant molecule, is converting into M. Okay, a hypothetical reaction. So what they have given? So in the questions they have given the initial, that is L value. So they have given what they have given? L value. Okay, initially how much it was? 10 grams they have given. Okay. And after that, they are telling that after 30 and 90 minutes, the L value is getting reduced to 5 grams and 1.25 grams. And they're asking determine the order of the reaction. So as soon as you look at these type of reaction, it is understood that it is kind of question based on T half, right? Why I am assuming that it's a T half related question? Because 10 grams of L in 30 minutes is undergoing reaction to give to remain at 5 grams, right? So 10 to 5 grams is nothing but half of the concentrations is reduced, right? So if half of the concentration is reduced, that is 10 grams to, okay, 10 grams to, if there is reduction to 5 grams, we say that the time required for the conversion of 10 grams to 5 grams is called T half, correct? So what would be the time? So here the T half is equal to 30 minutes. Okay, 30 minutes they have given, because at 30 minutes they are clearly saying that 5 grams of L is there, right? So hence 10 grams to 5 grams is T half, that is 30 minutes. Now usually if we check the pattern of this reaction, this 5 grams, okay, need to further convert it into what? If it is becoming half, then definitely then it has to become as 2.5 grams. Okay, once again from here, if you are converting into half, it has to become 1.25 grams. I'm sorry. So it has to become how much? 1.25 grams. Okay, 1.25 grams. So which means that when there is formation, or when there is 1.25 grams of L is left, the time was 90 minutes. The time was 90 minutes. So it is understood that for the conversion of, that is 10 grams, for the conversion of 10 grams to 5 grams is 30 minutes, then 5 to 1.25 grams is 90 minutes. So which means that we assume that 5 to 2.5 is also once again that is T half only, no, 5 to 2.5. So definitely it would be taking 30 minutes, and once again here also it is taking T half is equal to 30 minutes. So in overall these three T halves is equal to 90 minutes. So what is the pattern that we are trying to understand? Irrespective of the initial concentration, okay, irrespective of the initial concentration, the T half time is remaining same. Okay, so in which case the T half will be independent of the initial concentration. We all of us know the nth order T half. So what is the nth order T half? So T half of a nth order reaction is equal to 1 by a power n minus 1. Okay, so now we all of us know that if you put n is equal to, that is order n is equal to 1, it will become what? Basically a power 1 minus 1 is equal to 0. Anything raised to, that is T half is equal to 1 by a power 0. So a power 0 is equal to 1. So which means that you are assuming n to be first order. So if it is first order, then T half is independent of the initial concentration. So hence the answer is quite easily understood that it must be option C, which is nothing but option C, which is nothing but the first order reaction. First order reaction. So it is a simple logic where we try to relate to the initial concentration 10 grams to the final concentration that is left for L, that is 1.25 grams. And it is a pattern of question where there is the same T half is remaining for every concentration when it is reducing to half, and hence it is understood that T half is independent of initial concentration, and T half will be independent only when you assume the order of the reaction to be first order. So hence for 168th question, the option C will become correct. Okay, hope you understood, students. Now we will take up the other question. So before we take up, let me also erase this so that there is no confusion. Okay, fine then. Moving ahead. So what is the next question? So this question I had also discussed in our online session, doubt session once we had. So during that session, I had actually discussed this question, but once again, we will do it. What is being given in the question? For a reaction, dx by dt is equal to K of concentration of H plus, which is raised to the power n. If pH of the reaction medium changes from 2 to 1, the rate becomes 100 times the value at pH is equal to 2. The order of the reaction is. So quite simple. So we all of us know how to convert pH into concentration of H plus, right? So what is the formula for pH? So when you write pH is equal to minus log H plus concentration, minus log H plus concentration. What is being given? They have given two different values of pH. So pH, they are assuming for the first, rate, that is to be 2. Okay, pH is equal to 2. And second, when they are reducing the pH from 2 to 1, pH 2 to 1, they are telling that the rate is increasing by 100 times. So hence, basing on these two pH values, we will be writing two rate equations. Okay, so how to write? So we will write rate is equal to, when the concentration of H plus, that is corresponding to pH2. So how much will be the corresponding to pH2? We will write 10 power minus 2. Okay, when you assume pH is equal to 2, it will become 10 power minus 2. And when pH is reduced to pH1, what is happening basically? So basically, there will be formation of, that is when it is reduced to 10 power minus 1 concentration, the rate is increasing by 100 times, 100 R. Are able to understand? Now this will be our equation 1 and this will be our equation 2. Okay, so once again, like our initial rate method, what we are supposed to do? So we will divide equation 1 divided by equation 2. So what will happen basically? R by 100 R is equal to 10 power minus 2 divided by 10 power minus 1. So whole power n. So where n is determined. Now what do you get basically here? If you cancel r and r, you will get 1 by 100, which is equal to, you will get 1 by 10. Okay, 1 by 10, correct? So now 100 can be written as 1 by 10 square is equal to 1 by 10. Okay, and this is actually having the power n. So here also it is having the power n. So now, bases are same, that is 1 by 10 and 1 by 10 is same, and hence n is equal to 2. N is equal to 2. Okay, so hence what is the order of the reaction? So order of the reaction is nothing but option B, that is second order reaction. This is second order reaction. Okay, hope you understood this. Now let us take up the next question. Okay, so what is the next question? Just have a look. Okay, now coming to the next question, where we have something called homogeneous gaseous reaction. So I had told you that for gaseous reaction, you cannot directly write the first order rate law, where we know that 2.303 by T log Pi by Pi minus X. So it has to be systematically solved. Let us now write the hypothetical reaction. So what is the hypothetical reaction? Here it is given as A, okay, A is giving rise to 2 moles of B plus C. Okay, so what do we have to assume? Basically, they are asking if the total pressure after time T was PT, and after a long time, that is when T is becoming infinity, was P infinity, then K in terms of PT, P infinity, and time. So which means that we have to express the rate equation, that is first order rate equation, in terms of pt, p infinity and t, when these are the conditions. What are the conditions? At time t the total pressure is pt, and at time infinity the total pressure is p infinity. Now how do we basically approach these type of questions? We have to write all the conditions, right? So what are the conditions? When t is equal to 0, initial concentration is pi, and similarly there will be no formation of products, right? So similarly, if t is equal to t, okay, if t is equal to t, what will happen to this concentration? It will become pi minus x. So here there will be formation of 2x moles of b and x moles of c. And also I have told you that here why are we writing 2x and x? So 2 here refers to the stoichiometric coefficient, so which means that the formation of product will be equal to the total partial pressure of 2 moles of B. So hence it has to be written as 2x, and here only 1 mole of C is formed, and hence that corresponds to only 1x. Okay. Now similarly we will also write when t is equal to infinity. So what will happen? So this entire A will get consumed, and hence that will be equal to two initial pressures of B, that is 2 pi, and here it will become 1 pi. Understood? Now what we are supposed to calculate? So in the question they are asking us to determine when time t is equal to, t, what is the pt, and when time t is equal to t infinity, what is p infinity. So these two terms we are actually going to determine. Now let us begin with how to determine p infinity, sorry, pt. Okay, now I will make a line here. Okay, now what are we going to do? We are going to do pt. So how do you calculate pt? It is nothing but the summation of all these pressures, that is the pressure of reactant A, and pressure of partial pressure of product 2b, and partial pressure of C. Okay, now pt is equal to summation of all these three things, right? So when you do summation of this, so let me write completely, where you get pi minus x plus 2x plus x. So this x and this x gets cancelled. So hence, what do you get? You get, sorry, you get pt is equal to pi plus 2x. Correct? Now, from here, basically you can determine the x value. So what is the x value? So it becomes pt minus pi divided by 2. pt minus pi divided by 2. Are you able to follow, students? Yes. So next step we will do, as x value is calculated. Now this x value need to be substituted when we have p, that is at time t, this entire value we need to determine, that is pi minus x. So now we know that pt is equal to, where is it? I will write here. We know that when time t is equal to t, pt is equal to pi minus x. So now substitute the value of x here. Okay. So if you substitute the value of x here, what will you get? So pt is equal to pi minus of, whole brackets, you will write pt minus pi divided by 2. Take LCM for both the things, then it will become pt is equal to 2 pi and minus pt plus pi, because minus of minus becomes plus pi. So hence you will get what? You will get what? So divided by 2. Divided by 2. So hence this will be equal to 3 pi minus pt, okay, divided by 2. So divided by 2. Okay, I'll rewrite because there is little overlapping. I will write it neatly. So what you have got, students? You have got pt is equal to 3 pi minus pt by 2. Okay. Now this is what is the value of pt. Okay. Now similarly, we will also determine what is p infinity. When time t is equal to infinity, the total P infinity, that is pressure at infinite time, will become 2pi plus pi, which is equal to 3pi, right? So hence P infinity is P infinity is equal to 2pi plus pi is equal to 3pi. Now from here, determine pi value. So pi value will become what? So pi value will become what? So pi value will become pi is equal to P infinity minus 3. Now, since in PT, that is pressure at total time, that is pressure at time is equal to T, this is what you have determined the value. So here also you have something called pi. So now this pi value will be substituted by P infinity by 3. So hence what do you get? What do you get, students? So here I'll write it for PT. So PT is equal to 3 pi minus PT divided by 2, you have got, right? Now in this case you will be substituting by P infinity by 3. So if you are substituting P infinity by 3, what will happen basically? I'm sorry. So here I'll write, what is it? 1 second. So 1 second, what is happening? Yeah, here it will become 3 into P infinity by 3. So which means that this 3 and this 3 gets cancelled. So minus PT by 2. So overall, what will be the PT? What will be the PT? So PT will become PT will become P infinity minus PT by divided by 2. Now substituting the PT value as well as there is the PI value. So this value, okay, in this rate expression, you will get, what do you get? K is equal to 2.303 by T log. So in the place of Pi, you will put P infinity by 3 divided by, in the place of Pi minus x is nothing but Pt. So where Pt value is calculated to be P infinity minus Pt divided by 2. And if you rearrange, you will get an equation where K is equal to 2.303 divided by T log, okay, 2P infinity divided by 3 into P infinity minus Pt. So now let us have a look which option is correct basing on this. So which option is correct? Option C is correct. So this is how we are supposed to solve these this type of questions. Okay, these type of questions. So hope you understood this. Now we will move ahead with the next question. Okay, 1 second. Just have a look at the next question quickly. So now we are going to solve the next question, which is nothing but the ratio of the times of 99.9% of the reaction to complete. Okay, let us take up the next question without any delay. So this is such a direct question where the ratio of the times for 99.9% of the reaction to complete and half of the reaction to complete is, this is basically the first order reaction where we know that T99, okay, so T99.9% is equal to, okay, 10 T half, 10 T half. So hence the value is a direct based on this equation. So hence the value is directly, we can predict, which is nothing but option D is correct. Option D is correct because this is the relationship between for a first order reaction, 10 T halves will be equal to T 99.9%. Okay. So now let us quickly take up the next question. So what is the next question? Basically, it is all about, okay. Once again, a simple question. So directly we will solve it. Okay. Okay, 172, right? Yeah. So now, what is this question all about? The rate of the simple reaction 2NO plus O2, 2NO2, when the volume of the reaction vessel is doubled. So this is kind of a simple question only, but basically this reaction is all about, this is a gaseous reaction where 2 moles of NO is reacting with 1 mole of O2, and 2NO2 is being, what do you say, formed, and they are telling that the reaction vessel is doubled. So when you double the reaction vessel, basically the concentrations will be reduced. First of all, to solve these type of questions, we need to write the rate law. Okay, first let us write the rate law. So where rate law, so rate is equal to K into concentration of N, is it NO? Okay, NO, which is no, raised to the power 2, raised to the power 2, and then you have concentration of O2, which is raised to the power 1. So which means that the order of the reaction is identified to be 3. Now what we have to basically do it. So now we assume the concentration here to be, that is partial pressure of NO to be 1 and partial pressure of O2 to be 1. So now what they are doing, basically they are doing double the, they are, what do you say, the volume of the reaction vessel is doubled andre enagutte, partial pressure, it will be reduced to half, right? So hence rate 2 will become what? It is rate is equal to K into, I can assume this to be 1, and here also I can assume to be 1. So which is equal to 1 square into 1 is equal to 1 right here. Okay, now here what is happening, basically in the second case they are doubling the concentration, right? So hence I will write 1 by 2 whole square, and then here also 1 by 2, okay, raised to the power 1. So which will become what? 1 by 4 into 1 by 2. So which means that it becomes 1 by 8. So now what is understood? So the rate will be, remember, there is a law called law of mass action. So according to law of mass action, if the concentrations are more, concentration of the reactants are more, the rate of the reaction also will be enhanced, right? So if, according to the same case, if gaseous reactions, if you are taking, in order to represent the concentration in terms of, gaseous reaction, we will use partial pressure, right? So if the pressure is reducing, definitely the rate of the reaction will also reduce, and hence here 1 by 8 value corresponds to what? uh, will grow 8 times of initial rate. Will it be correct? No, obviously. So then there can't be, increase in the rate, and hence there should be rate reduced to 1/8 of the initial concentration. So hence option B would be correct option for 172, question number 172. Okay, so hope you understood this. Now we will take up one more question quickly. Okay, so what is this question? Next question. So next question is once again based on the same mechanism, equilibrium reaction mechanism, which we have already seen. One of the examples, in which question number do you remember? So which question? 167th question. Okay. So now according to that only we will be solving 173rd question. Okay, just have a look at the reaction. The reaction shows 2NO plus Br2 giving rise to 2NOBr, and since this is not an elementary reaction, it's a complex reaction, they are giving the mechanism. So the first reaction is said to be the fast equilibrium reaction. Second step is said to be the slow reaction. So we all of us know that the slow reaction is the rate determining step. So basing on the slow reaction, we will write the rate equation. So how do we write the rate equation? All of you know how to write, right? So rate is equal to, K into concentration of, for the slow step I'm writing NOBr2 and NO. Okay. Now, if you carefully look into the rate here, which is derived based on the slow reaction, we don't have NOBr2 term in the overall reaction. Do you find NOBr2? No. So hence this rate law is wrong. So hence, what do you have to once again look into the mechanism? You look into the mechanism where there is a fast equilibrium step, right? So in case of fast equilibrium step, you are getting the product, that is NOBr2, as soon as it is formed, it is getting consumed in the slow step. So which means that it is said to be the intermediate. Okay, so basically intermediates cannot become part of the rate law. Okay, so according to that concept, we will define equilibrium value for this reaction. K equilibrium we will write. So what will be the K equilibrium value? K equilibrium value is equal to the product concentration, that is NOBr2 of the fast reaction, divided by concentration of NO and concentration of Br2. Okay, Br2. Okay, now if you want to replace NOBr2 term from rate law, you have to get the value of NOBr2. So how do you get? So you will get in this way. So NO as well as Br2. Now substitute this value in which equation? Here in this equation. Okay, so hence what will happen basically? So rate will become equal to, so rate is equal to K into KEQ into, so NO Br2, and then one more NO was already there. So hence this is what. So what do you get basically? Product of K and KEQ can be written as K dash, and then it is taken as NO square and Br2. So this is what is the correct correct term, and they are basically asking you to determine the rate of the reaction when you change the concentrations of these two. So if you have to determine the rate of the reaction, first thing is that you should be knowing what is its order. So if you don't know the order of the reaction, definitely we cannot predict what could be the rate of the reaction. Are you able to understand? So hence that is the reason we have now first determined the rate law in which we can actually determine the order of the reaction. So what is the order of the reaction based on the rate law that we have written here? So it is understood that the order of the reaction is 3. Order of the reaction is 3. So now read out the second part of the question. What is it? If the concentrations of both NO and Br2 are doubled, then the rate of the reaction would become what? So this is the initial rate. Now what they are doing? They are doubling it. So when they are doubling it, they are asking you to determine how many times the rate will be increasing, right? So what you are supposed to do? Now here you will write for the increased rate when the concentrations are doubled. So it will become 2 square and it will become 2. Okay, so that becomes 8 times. That is, rate is increasing. 2 power 2 is 4, 4 twos are 8. So 8 times the rate will increase. So option C is correct. Okay, without determining order of the reaction, definitely you will not be able to solve this question, because they are asking if the concentrations of NO and Br2 are doubled, then the rate of the reaction would become how many times? So in order to solve this question, first and foremost important thing is to determine the rate law, that is this. So if this rate law is not being determined, then how will you substitute here as 2 power 2 and 2, not possible, right? So hence we have to first determine the rate law. Second, we will determine how many times the rate is increasing if the concentrations are doubled. So hope you understood this question. Now we will take up the next question. Okay. So what is the next question, students? Once again, it's quite simple question. So what is the simple question, what they have given? Okay, let us have a look at 174th question. So what is 174th question? Right. 174th question. So here they are actually giving a graph, and to that they are also giving a question here. What is it? The accompanying figure depicts the change in concentration of species x and y for elementary reaction x2y, which means that x is the reactant and y is the product, as a function of time. The point of interaction, that is intersection of two curves, represents. So we all of us know that according to rate, the concentration of reactant should decrease. At the same time, the concentration of product should increase. That is what is rate. So we define rate to be decrease in the concentration of the reactant, which will be equal to increase in the concentration of the product, right? So now this is the concentration and this is the time, this is the reactant and y is the product. Now when these two lines are meeting at a point, what this corresponds to, right? Basically, if they mention order of the reaction, that this is so and so order, then the value will be we cannot say that okay, fine, let me first explain this. So if you see, the amount of x decrease is actually equal to the amount of y increased, correct? No, the amount of x decreased is basically is equal to the amount of y increased. So x and y, we can also say that this corresponds to, that this point of intersection corresponds to t half, right? So what is t half basically? So t half is nothing but the time required for the conversion of amount of x, okay, to half of its initial concentration. Only if the half of its initial concentration is converted to y, you will get concentration of x is equal to concentration of y. So hence this graph at the point of intersection basically corresponds to t half, basically corresponds to t half. So am I clear, students? Am I clear? Hope it is clear. It is quite simple. What I'm trying to say is, so the amount of, that is the concentration of x is basically becoming concentration of y. So when this condition will apply? Only when the initial concentration, that is initial concentration, let us assume x to be a. If x is becoming a by 2, if x is becoming a by 2, then y will also be a by 2. So which means that these two are equal. So this is generally is nothing but the t half. That is time required to reduce the initial concentration to half, correct? No, so hence this is t half. So option A is correct. Next one is 175 question. So what has been given here? The reaction between A2 and B2 follows the equation A2 plus B2, which is giving rise to 2AB. Okay, so the following data observed. The following data is observed. So what is the data observed? So here they have given A2 naught, that is initial concentration of A2, and B2 naught, that is initial concentration of B2, and here they are giving initial rate of appearance of AB. Okay, now they are asking you to determine the value of rate constant for the given reaction is. So before determining what is its value of what do you say, uh, rate constant, we are also supposed to determine something called the order of the reaction, isn't it? So without determining order of the reaction, we will not be able to determine the rate constant, correct? So hence our first step will become very important to express the rate law with the concentration of reactant terms raised to the powers, that is x and y. So first of all, let us do the initial rate method only. So how do we do initial rate method? So let us now start with simplifying the initial rate method. So we all of us know, because this we have done several times in several problems. Okay. Now let us take up this. So as usual, we assume this entire set of values to be equation 1, and this entire set of values to be equation 2, and this entire set of values to be equation 3. So which two equations shall we take now? So we will take in such a way that the two values, if these two values are same, if you assume this is raised to the power y, let me write, I do not want to confuse you. So let us say rate, that is equal to, rate is equal to K into concentration of A, which is raised to the power x, concentration of B, which is raised to the power y. Okay, this is how you generally write the rate equation, correct? Now substituting the values of concentration of A and concentration of B. Okay, substituting the values of concentration of A and concentration of B in this rate equation. In this rate equation, we will be now able to, make the equations, three equations. Okay, now directly we will be taking equation 2 divided by equation 1. Where is equation 2? This I'm assuming to be equation 2 divided by equation 1. So I'm directly writing. So where rate of equation 2 is 5 into 10 power minus 4. I will write that only. So here 5 into 10 power minus 4 divided by 2.5 into 10 power minus 4, which is equal to concentration of equation 2 in A is 0.2 divided by 0.1, which is raised to the powers x. So this is also raised to the power x, and which is multiplied by 0.10, that is concentration of B y divided by 0.10 y. So we need to always take where the powers exactly matches so that it gets cancelled, and we will easily derive at, at least either the power of x or y directly, right? So now 10 power 4 and 10 power 4 gets cancelled, and now this will become what? 2.5, that is 5 divided by 2.5 is 1, and then it is 2. Okay, it is 2. So now it is becoming what? So 2 is equal to 2 power x. Now x value you are identifying to be 1, correct? Now similarly, we will also solve equation where you have values of A is same now. So 20 and 20 is same, and these two are different, and hence we will take up equation 2 and equation 3. Now divide equation 3 divided by equation 2. So what is equation 3 value? So equation 3 value is, it is 10 into 10 power minus 4 divided by 5 into 10 power minus 4, which is equal to concentration of A is same, so which is raised to the powers x, and this is also raised to the power x, into 0.20 by 0.10 raised to the powers y. Okay, this is also raised to the power y. Now what will happen? So if you cancel this and all, this and this gets cancelled, and here 10 power 4 and 10 power 4 gets cancelled, and this is 5, and here you will basically get 2, right? So you will get 2 here. Now it is equal to how much now? It is equal to how much now? So 2 power 1 is equal to 2 power y. So y is equal to 1. Now we understood what is the rate law for this reaction, that is A2 plus B2, where there is formation of 2 moles of AB, right? So hence we will write What will, how do we write a rate? I will write here. So rate is equal to K into A, that is A2, which is how much is the value of X? So we calculated the value of X to be 1, right? X to be 1 and Y also to be 1. So which means that it is a second order reaction. It's a second order reaction. Okay, it's second order reaction, that is B2. Now we have to basically do the what do you say, calculate value of rate constant. We have to calculate the value of rate constant, that is K. So how do you convert this? Because we know the rate, we know the concentrations of A2, and also we know the concentration of B2, correct? Now, how do we determine K? We know the formula, that is K is equal to rate divided by A2 and B2. Rate divided by A2 and B2, no? So, rate divided by, that is concentration of A2, concentration of B2. This is A2 and concentration of B2. So now here is the twist. What is the twist means? Basically here they have given initial rate of appearance. So how much it is appeared? Basically 2 moles of AB is appeared. So if at all, if the appearance is being given in terms of products, we know how to write the rate law, isn't it? So how do you write rate law for this equation? So rate law means what? Differential rate equation, right? So how do you write differential rate equation for this equation? So this equation will become, let me write here, that is decrease in the concentration of A2 with respect to, I'm sorry, let me write neatly. Okay. So how are we going to write? So I will start writing from here. That is decrease in the concentration of dA2 by dt is equal to minus dB2 by dt, which is equal to 1 by 2, that is plus dAB by dt. Are you able to understand? Now, what basically we are understanding, dA2 by dt is equal to minus dB2 by dt is equal to half of dAB by dt according to differential rate equation. So hence, when you are determining rate, okay, that is K value. When you are determining K value, the rate and concentration of A2 and B2, what will happen? So this 2 will go and do the product, right? So it will be multiplied with 2. So hence, among this entire data table, any of the rates can be taken. That is, initial rate of appearance can be taken. If you are taking the last one rate value, how much is the rate value? 10 into 10 power minus 4. So substitute those values here in this equation. So hence K is equal to rate 10 into 10 power minus 4 divided by, what is the concentration of A naught and B2, A2 and B2. This is 0.20 and this is also 0.20. So the product of these two will become how much? 0.40. I'm going to write directly because A2 is also raised to the power 1, B2 is also raised to the power 1. Okay. Now, but then here, basing on this rate equation, this will become the product, that is 2. You have to write 2 into A2 and B2. So here it will become how much, students? It will become 2 into 0.4. Now, if you simplify this, this will become 5. Okay. So 5 into, that is, let me write here. So K is equal to 5 into 10 power minus 4 divided by 0.4 will be equal to 1.25 into 10 power minus 2. So hence the rate constant value will become equal to option C. So which is your correct option here? So that is C. So what you are basically doing, I just give you a quick recap of this question. So basically, whenever you are getting this box type of problems, you will be expected to solve the order of the reaction by doing initial rate method, and you will get to know this rate law. Okay, once you get the rate law, you will be asked to determine the rate constant, and be careful while determining rate constant, because that depends upon the rate law once again. So what is the rate law? Differential rate law. This is how we express. Okay, so now DAB, that is initial rate of appearance, with respect to this they are asking the rate constant, and hence this 2 will multiply with the concentration of A2 and B2. So hence rate, any of these following three sets of data can be taken. Even if you take this 5 into 10 power minus 4, you will multiply these two concentrations. Okay, or if you want to take 2.5, and then you will multiply with these two concentrations divided by 2. So any of the sets can be taken, but here I have taken the third set of value, where K is equal to rate by 2 into concentration of A2 and B2. So if you simplify that, you will get the value of K to be 1.25 into 10 power minus 2. Hope you understood. So if you have any questions, you can also ask me during our class hours. Okay. So next question is what? So next question is once again simple, which is based on the T half, nth order of T half, right? So what is the question asked? Just have a look at the question quickly. So we will be solving that question too. Okay. Now what is this question, my dear students? Okay. Now what is this? The half-life period for catalytic decomposition of AB3. So they are giving for AB3, okay, catalytic decomposition, okay, and half-life of AB3 for 50 mm, that is 50 millimolars is given to be how much? 4 hours. For this they are giving 4 hours. And once again they are taking one more different initial concentration, that is 100 millimolar, and that is being the half-life of 100 millimolar is given to be 2 hours. Once again, this is pattern of questions based on T half of, that is T half, which is directly proportional to 1 by A n minus 1, right? So according to this, I had told you that if T half of a first order zero order reaction, then one second, T half of a, so T half of a zero order reaction becomes what? So it will be directly proportional to initial concentration for a zero order reaction. For zero order, for zero order reaction, T half will become what? T half will become what? T half will become directly proportional to A, correct? So T half is directly proportional to A. But for a first order reaction, so for a first order reaction, what will happen? T half will be proportional to 1, which means that independent of concentration of reactant. Okay. But for second order reaction, what happens basically? Second order reaction, so T half will be inversely proportional to A, inversely proportional to A. Now, keeping all these, formulas in mind, we can easily solve this question. So how do we solve? Look at this. See, if the initial concentration is 50 millimolar, the time taken, that is T half, is 4 hours, whereas you are increasing the concentration but time is decreasing. So this relationship is matching exactly with the second order, correct? No, so T half, that is T half 2 hours, is decreased from the initial one, because in the first case when you are taking 50 mm, that is 4 hours, whereas in case of second initial concentration, that is 100 mm, which means that you are increasing the concentration. Here the concentration is increasing, whereas time is decreasing. So this condition will be applicable only in case of second order reaction. So hence this is kind of pattern question based on T half, and hence you can easily predict the answer. So where the order of the reaction is identified to be 2. Okay, so this is 176th question. Okay, now once again a similar equilibrium steps involving a complex reaction is being given. What they are basically asking, to determine rate of reaction, that is rate law you are supposed to give for this complex reaction, and these are the 3 different steps. Now just have a look, since we have solved so many of these questions. So what becomes important in case of complex reactions? The slow elementary step will become important, and before the slow step, whichever the number of fast steps comes, those are all important, whereas after the slow step, this fast step will become insignificant. Okay, so hence these 2 steps are very, very important. And if you look at carefully, the first step is said to be the equilibrium fast step, and second step is the slow step. Our main focus need to go on the slow step only initially. If you write the rate law for the rate determining step, which is nothing but slow step, you will get the concentration of the 2 reactants which are involved in the slow step. Which are the 2 reactants that are being involved in the slow steps? So which is nothing but N2O2 and H2. N2O2 and H2. But look at the overall reaction. Do you find N2O2? Do you find N2O2 in the overall reaction? No. So hence, what it is understood? It is understood that N2O2 is an intermediate. N2O2 is an intermediate, correct? No. But still, we will practice. During practice sessions, you have to write it completely. So let me write the rate determining step. That is, rate is equal to, for the slow step, what is the rate? So I'm writing K2 into concentration of N2O2 and concentration of H2. Okay, now what will happen? Basically, this N2O2 is not part of the overall reaction, and hence this rate law, if you are directly giving, then this will become wrong. So what you are supposed to do? You need to substitute N2O2 value that can be derived from equilibrium step. So equilibrium, it is written only NO, right? So it is understood that when you write equilibrium, how do you write? So K equilibrium is equal to N2O2 concentration divided by, it is understood that NO square. So now what is the value of N2O2? N2O2 is an intermediate where it cannot be part of the rate equation. So hence it will become NO square. Now this value will be substituted in the place of this here. So it will become what? Now rate is equal to K2 into K equilibrium, then it is NO square and H2. Understood? Now product of K2 and K equilibrium, both of them are constant, and once again it will become K dash, and it will become NO square and H2. So now if you look at, if you compare this rate law with the overall reaction, it will be consistent. Why it will be consistent? You will also see in case of this reaction where there is NO is there and also there is H2, and hence this will be, so this will be correct. So which option is correct according to the solution that we have done? So option A would be correct. Option A would be correct. Okay. Now we will take up the next question. So what is the next question, students? So next question is basing on once again first order reaction, right? So what they are giving? So they are giving that for reactant, when the concentration of 0.8 molar is getting reduced to 0.4 molar. It is taking 15 minutes. So from this step itself, it is understood that they have given T half, right? So 0.8 and 0.4, how they are related? They are related as half of the concentration of the initial, and hence what is being given, students? So it is given that T half for a first order reaction is 15 minutes. Okay, and what they are asking now? They are asking the time taken for the concentration, okay, to change from 1 molar to 0.025 molar. So hence what you have to determine? You determine K value. So how will you determine K value? K is equal to ln 2 divided by 15 minutes. Okay, 15 minutes. Either you can express in terms of ln 2, or you can also write it in terms of 0.6693, but to avoid so much of calculations, you can also take ln 2. Now substitute this K value in the first order reaction, where K is equal to, I will write in terms of ln only, that is natural logarithm. So hence, anyhow we need to determine T, right? Because here it is asked the time taken for the concentration to change from 0.1 m to 0.025 m, right? So hence I will write in terms of T. So when you are writing in terms of T, it will become 1 by K ln, what is the value that they have given? So ln 1 m, that is 0.1 m divided by 0.025 m, right? So now you know the K value. What is the K value? Substitute. Where is it? K value, that is ln 2 by 15 minutes. So if you are substituting ln 2 by 15 in the place of K, you will get here ln 2 into 15, and here this, if you simplify these two, that is 0.025 and 0.1, it will become 4. So you will get ln 4 here. Okay, now how will you write ln 4? So ln 4 can be written as 1 by ln 2 into 15 into 2 ln 2. So ln 2 and ln 2 gets cancelled, and 15 twos are, it will become 30 minutes. 30 minutes. So which option is correct? Option A is correct. Okay, option A is correct for 178th question. Okay, now we will take up the next question. So that is also once again based on, what is it, my dear students? It is completely based on the first order reaction. So now let us understand what they have given and what they are asking for. Okay, so the given is the 3 graphs. So what are the 3 graphs that they have given? So this is the graph 1, where the graph is plotted between log a minus x and time, and here log a by a minus x versus time, and here T half of and concentration. So we all of us know that for a first order reaction, T half is independent, okay, independent of concentration of reactant, right? Reactant, and hence the third graph, this is wrong. So why this is wrong? If you are plotting a graph between T half and concentration of reactant, basically how do you get? You have to get a parallel line like this, which will be parallel to the x-axis, that is concentration axis, right? So this is wrong. So this graph is wrong. Now coming to these two. So we know the equation, how it can be derived. I would have given the, during the derivation of first order integral equation, where I would have told something like this, that is, what do you say, kt is equal to, okay, ln a naught by a, right? So what is kt ln a naught by a? So a naught is the initial concentration, a is the concentration at time t. So if you assume a hypothetical reaction, a is giving rise to b, when t is equal to 0, initial concentration is a, that is a naught. Okay, when t is assumed to be t, that is, wait a minute, when T is assumed to be T, then there will be formation of x moles of product, and hence it will become A minus x. So this A minus x only we will correspond it to the concentration AT, correct? Correct. Now this, if you convert this into log, then what will, how it will become? Basically, it will become as KT is equal to, it will become what? 2.303 log A naught by A. A naught by A. So if you are doing like this, so they are plotting the graph between T and log A naught by A. So this 2.303, I will bring it on this side. So it will become K by 2.303 into T is equal to log A naught by A. Okay. Now this is basically is equal to mx, correct? Y is equal to mx, linear regression formula, right? So if you are taking on the y-axis log A naught by A, on the x-axis time, and you get the slope, that is k 2.303, and it's a positive slope and no intercept, that is c is not there. So hence it has to pass through the origin. So graph 2 is absolutely correct. Graph 2 is absolutely correct. Now similarly, if you are plotting a graph for log A minus x and t, now we understood that A minus x is equal to AT, right? So A minus x is equal to AT. So hence for this, what is the equation? So equation is nothing but, that is ln AT, concentration of A, is equal to ln A naught minus kt. So what will become? So this is once again equal to y is equal to, this is mx and this is c. So slope is negative, and hence if slope is negative, there will be decrease. Okay, so the graph will be like this only, like it will decrease, correct? No. And there is also an intercept c, which is nothing but, so this point of intersection, if you extend this line here, you will get what is this? Ln A naught. And hence even the first graph is absolutely correct with respect to first order reaction. Even the second graph is also absolutely correct with respect to the first order reaction based on these two equations. And hence we say that option B is correct. That is 1 and 2 are correct, and C is, that is third option is wrong, because you need to get a graph like this. Okay, so hope you understood. And we are at the last question of NEET. So let us also understand the last question too. So it is based on carbon dating, right? So carbon dating, one thing you have to keep in mind. What one thing that you need to keep in mind? There are two important things that need to be kept in mind. What are the two important things? One is, if any plant is freshly cut, we say the activity, C14 activity, to be initial concentration. We consider that to be initial concentration. Why? That was freshly cut, which means that the activity of that is dN by dt is directly proportional to n, or otherwise we will also write dN by dt is equal to lambda n, right? So now for a freshly cut plant, n will be equal to n naught. That is assumed to be initial concentration. And here they have given wooden artifact. So wooden artifact means it is cut for, we don't know, like how many years, months, days, we don't know. Definitely the C14, whatever is there, that will remain constant. That will remain constant in the sense C14 will be declining, and hence there will be what do you say? We generally assume wooden artifact to be NT. Okay. So what they have given in this question, wooden artifact and freshly cut tree, actually the values of C14 is being given as 7.7 and 15.4 minute inverse and gram inverse of carbon 14, and whose half-life is being given to be 5770 years respectively. And now they are asking with respect to the freshly cut, that is initial concentration of C14, what would be the age of wooden artifact? Okay, so hence, how do we solve this question? So we know the formula where nt is equal to n naught into half, which is raised to the power n, right? So where n also we know that value of n is equal to total time divided by t half. Okay, now we knew what is the value of nt and what is the value of n naught. Substituting these two values, we will also get to know what would be the total time, that is this total time. Okay, now let us substitute the values. This expression can also be converted to nt divided by n naught into 1 by, sorry, not into, is equal to this one. N is nothing but what? Total time divided by t half, right? Now what is the value of nt? As I have told you, nt is nothing but the wooden artifact only will become nt, that is 7.7, and 15.4 is the freshly cut, and hence this will be assumed to be n not always. Okay, so now, what do you do here? How will you substitute? So I'm substituting NT value to be 7.7 and 15.4, which is equal to 1 by 2, 1 by 2. So total time we don't know. So that I will assume it to be X, and T half we know they have given 5770. 5770. Okay. Now this will become also 1 divided by 2. So which will be equal to, so bases are becoming equal, right? 1 second. So bases are becoming equal. 1 by 2 is equal to 1 by 2, which is raised to the power x by, x is what? The total time, 5770. So now 1 is equal to x by 5770. How 1? Because on this side, that is on this side, basically we don't have any powers raised to the powers, then it is assumed to be 1. Now bases are equal, so we will take the powers also equal. Now 1 is equal to x by 5770. Now x value will become what? 5770 years, and hence which option is correct here? So option A would be correct. So with this we are done with the chemical kinetics questions from NEET, what do you say, NEET exam question paper. So if you have any further queries, you can actually feel free to approach me, and also you can clarify your doubts during our class hours. Hope you have understood. With that note, thank you so much.